We're now ready to solve a system using matrices. And this is going to be particularly useful when we have matrices that are bigger, or systems that are bigger, that have x, y, and z, 3 equations and 3 unknowns. But I'm going to start with a simple example here. What we're doing, by the way, is called Gaussian Elimination, or what we're about to do in matrix form is called Gaussian Elimination, named after the mathematician Gauss. And so the idea of using matrices is to sort of kind of reduce this problem to its basic form, or is strip away all the unessentials that are here. So one thing we know is that like the x's and the y's they're not that essential. I can sort of encode this equation, or this system rather, by writing the coefficients of those variables like this. And then I usually put like a dash here and put the results, or those constants, on the other side. And this is important because, like, as long as we understand that this is column x and this column represents the y's and this represents our answers, then we're fine. As long as we can, if we can do all the manipulations we would do over here, but we're just going to do them without worrying about the x's and the y's. That's all. Now our goal is to turn this matrix here into what's called row reduced echelon form. And that is just a fancy term for this matrix that I'm about to write down. The one that looks like this. 1, 0, 0, 1. And then whatever your answers end up being. Because if I do that successfully, then since I know this is column x and this is column y, and this is my answer column, then this is just code, right? This matrix right here, row reduced echelon form, is just code for 1x plus 0y equals our first number. So basically then just x equals whatever x equals, and 0x plus 1y equals whatever y equals. So if I can turn the matrix into that form, then I will have encoded the answers. Okay? So what rules are we allowed to operate with? We're going to identify 3 of them here. Elementary row operations on a matrix that correspond to changing the equation of the system down here. So one thing you can do is you can interchange any 2 rows. So what I mean by that is if this is row 1, let's just say like that's row 1 and that's row 2, I can just flip them. I can put the 3, 2, 22 at the top and the 4, negative 3, 18 at the bottom if I want to do that. And that will not change the final answer. Okay? It's no different than taking this system over here and just writing the top equation on the top and the one that's on the bottom. It won't change the answers. So that's not too surprising. The other thing I can do is I can multiply all the elements of one row by a non-zero number. So it has to be non-zero, because if I just multiplied the top row and the bottom row by 0, then I would just get zeros everywhere, and that doesn't reveal any information about what x and y are, right? But I can multiply them by like 2 or 3 or whatever, any other number besides 0, and it won't change what x and y ends up being. And in other words, it's not going to change what this final answer matrix is going to look like. Okay, and then the last thing we can do is we can add a multiple of one row to any other row. So we can add a multiple of one row to any other row. Okay, so I can multiply the top row by 2 and then add it to the bottom, and it won't affect the result. In fact, it'll probably, by doing that, it'll help me get to the result, and that's sort of the goal. So let's start. Now so again, remember our goal, this is our goal, to get it in the row reduced echelon form. The easiest thing to do is usually to get a 0 in that bottom left, okay, and that's, so generally the way this works is you get a 0, you focus on column 1, and you try to get a 0 in that bottom left hand corner, okay, because by doing that you sort of killed the x, the coefficient of the x in equation 2, and all that's left is the y, and once you're there, you basically can identify what y is and then work backwards. So again, we're going to try to get a 0 at the bottom left first. So to do that, I need opposites in column 1, right? So how do I get opposites? Well, looks like I have a 4 and a 3. Let's multiply the top equation by maybe a -3 and the bottom by a 4. And then we rewrite our new matrix. So I like to draw arrows to kind of show how the matrix changes. So now the new top row is -12, 9, -54, and the bottom is 12, 8, and 88. Okay, now what I can do is I'm going to add row 1 to row 2. So what happens when I do that? Well, the bottom equation, I'm going to change the bottom. -12 plus 12, that becomes a 0. 9 plus 8 is 17. And -54 plus an 88 gives me a 34. Now you might think, when we add the equations, don't they just turn into one equation? Well, by adding the two equations, you produce a new equation. In other words, you produce this new row here, 0, 17, 34, but you're allowed to keep any of the old ones if you'd like. So I'm going to keep that top one, right? Because that's still, I mean, those still represent the coefficients in the answers in my original system here, slightly changed. But that's not going to change the answers. So there's nothing wrong with adding them and then just keeping one of them, rewriting one of them. So now what? Well, if you look at the bottom equation, I'm going to use rule 2 up here, or operation 2, and I'm going to divide or multiply the bottom equation by, or the bottom row, by 1 over 17, or divide it by 17. So however you view it, multiply by 1 over 17 or divide by 17, it now looks like this. So 0 divided by 17 is 0, 17 divided by 17 is a 1, 34 divided by 17 is a 2. So notice we're on our way, we're getting closer. We're getting closer to our goal up here, right? I've got a 0 and a 1 at the bottom, that's what I want. I'll copy down that top again, -12, 9, and a -54. Now what I'm going to do is I got to kill. So once you get a 1 here, that's really powerful. This 1 in this area, because what I can do now is I'm going to kill that 9 there by getting opposites in this column. And how do I get opposites? Well, I'm going to multiply the bottom equation by -9. So I'm going to do two things at once. I'm going to multiply the bottom equation by -9, and I'm going to write it below. So then right below this bottom row now is 0, -9, -18. And now I'm going to add it to the top row. So I kind of did 2 and 1 there. So by doing that, I've got 0, 1, 2, and I got this -12. -9 plus a 9 gives me a 0. -18 and a -54 gives me a -72. And so I'm really close to being done. I'm just going to divide the top equation by -12 to produce my new final answer. So by dividing by negative 12, I've got a 1, 0, and then negative 72 divided by negative 12 gives me a 6. And the bottom equation is 0, 1, and a 2. And so we've done it. We've solved the system. It's now in row-reduced echelon form, and this means that x equals 6 and y equals 2.